In this tutorial, we're going to look at the air sheet in the Zebra model. This is where we define the thermal losses that occur because of air moving in and out of the building and taking heat with it. So this is what the air sheet looks like in the Zebra model. On this side, we have a number of inputs, starting with an assumed infiltration rate. So this defines the uncontrolled movement of air through the fabric of the building, which may be through the building fabric material itself, and also through any cracks and holes there may be in that fabric. And this infiltration rate is based on a pressure of 50 pascals, which is typically the pressure that infiltration is tested at. And it will depend on both the form of construction you choose and also the experience of the construction team with building low-energy buildings. So the objective to build a low-energy building is to get this infiltration rate as low as possible. But you also have to be realistic about what can be achieved in your area based on the local experience with building low-energy buildings. So in our case, we're going to use a passive house value. And we require beneath this that you give a justification for your chosen infiltration rate. So we don't validate the value that you put in, but we do force you to input a value just to make sure that you've given consideration to this property. After that, we need to define the internal volume of the building. And then the number of occupants, the average number of occupants. This will dictate how much we need to ventilate the building, because we would typically ventilate the building a certain amount per occupant of the building. And there's some typical values we can use here. So in our case, we're looking at a home, so we'll just use the typical value for that. And once we've defined that, the spreadsheet will calculate our space heating demand and our space cooling demand, broken down into infiltration and ventilation, and also broken down for each month of the year. Now, one thing that's a little confusing about this sheet as opposed to others is that in general, the calculations move forward through the spreadsheet tabs. But in this case, there are actually some inputs that come from subsequent tabs. So actually, if we go into the space conditioning tab, there are some values relating to heat recovery of ventilated air and relating to the whether we have ventilation at all, which will affect the values in this air sheet. So we just have to bear in mind that if we change the heat recovery value, if we change whether we have fans or not, the values in this sheet will also change. If we go into a higher complexity level, we'll find there's a number of additional inputs into the air sheet. There's also a more detailed breakdown of how these values have been calculated. So the additional inputs are a ventilation rate, which is assumed at 30 if you don't go into a high complexity level. So this is the ventilation that will be required per person. So 30 cubic meters per hour per person is the passive house default. We can also define a shelter factor, which is how sheltered the building is from the wind. The more wind and the more infiltration we will have through the fabric. So the typical value is 0.7, but if you have a particularly exposed or less exposed building, you can change this value. So that's an overview of the air sheet. In the next tutorial, we're going to look at incidental gains.